Imagine this, you're a senior engineer, your corporate laptop is well patched, your VPN is on, and your role says admin. So why did the system just block you from accessing a file you just created yesterday? It is because your location changed. Welcome to modern access control, where who you are matters less than where, when, and how you are asking. In this episode, we tear down static roles and rebuild access from attributes, relationships, and risk. No more trust but verify. Only never trust, always re-evaluate, right? Access control has evolved significantly from simple file permissions to dynamic risk-aware systems. Modern models focus on agility, attribute richness, and continuous evaluation. Let's go to our first access control model, and this is attribute-based access control, or ABAC. ABAC is the dominant model for complex distributed systems such as cloud, IoT, microservices. It uses attributes such as characteristics of an entity, environment, actions, resource classification to make authorization decisions. The core concepts around ABAC are, as I said, attributes, looking at metadata about subjects. These are users or user roles or clearance clearance levels. We look at attributes of an object such as file classification or owner, and actions. Actions could be read, write, delete, update, and finally the environment, which speaks to elements such as time, location, and device trust. Then another critical thing is policies. So logical rules are expressed as booleans. A boolean is a yes or no, or a one or a zero. Then we have a policy decision point, or a PDP. This is the engine that enforces this is the engine that evaluates policies against incoming attributes. That's the PDP. Then we have a PEP, or policy enforcement point. What does it do? It's the interceptor that enforces PDP's decisions to allow or to deny before access is granted. Then finally, we have policy administration point, or PAP, the interface to create, update, and delete policies. So another element is context awareness, real-time, e.g. to allow users if the IP is in the corporate IP block and device is well patched. That is real-time awareness. So from a GRC alignment point of view, I would say ABAC has a strong alignment with NIST SP 800-162. It also enables fine-grained, dynamic, and access control. Let's jump to the second access control model, and this is well known, especially if you handle complex corporate enterprise web applications or portals. Then you'll have come across this very common access control model, that is role-based access control. And though not new, RBAC remains widely used, but now hybridized with ABAC. Modern RBAC includes hierarchical roles and constraints, respective constraints. The key thing is roles, and then followed by constraints or permissions. So what are the core concepts of RBAC? Number one, a role. This is a job function. For example, a nurse, a cashier, a manager, with associated permissions. The other characteristic is role hierarchy. A senior role inherits permissions of a junior role, e.g., a manager inherits roles of an officer. Then the other thing is, the other aspect that defines RBAC is separation of duties, or SOD, SOD. This prevents a conflict of interest, e.g., the same user cannot have both a create invoice and approve invoice. So you find that an officer can raise an invoice, but the approval will be done by someone higher, right? Then there's an aspect of role assignment. Users are assigned roles. Roles are assigned permissions. Then finally, session activation is a feature. a user can activate a subset of their roles for a session. That brings in the aspect of least privilege. So in the modern days, the modern implementation of RBAC is that access-based access control, or ABAC, is layered on top. For example, a doctor role can access patients' records only if the patient region coincides with the doctor's region. So from a GRC point of view, RBAC is widely used in SOX, HIPAA, and ISO 27001 for ISMS, and it supports auditability and governance. The limitations that I have seen is a role explosion in complex environments where you have multiple roles with cross-cutting functionalities. So there you'd find there's an intersection of permissions between different roles, and if not well managed, then you are in deep trouble. Then the other limitation is it's static and not context aware like ABAC, and that's why we are layering access attribute-based access control on top of RBAC. So number 3, let's go to the third model, which is policy-based access control, or PBAC. So often used interchangeably with ABAC, policy-based access control emphasizes on human readability and declarative policies. It's separate from the application code. So you might have an interface that defines the policies for various entities, devices across various resources. So it is a broader paradigm, and let's look at the core concepts within it. So policy-based access control is, as it said, based on policy. A policy can be viewed as a high-level rule, e.g., only executives can view quarter 3 board decks from non-corporate devices, right? Everyone else then, therefore, has to view those reports from corporate issued devices. So that is an example policy. Then we have policy sets. So these are a group of related policies with combined algorithm. For example, first applicable or deny overrides. So here it says for first applicable, if you meet a particular condition, then you have access to a particular resource. And deny overrides is if a particular condition is found to be contentious, then there could be an override to it, creating some flexibility, right? Then the other thing is policy information point, or PIP. So this retrieves missing attributes. For example, a user's current location from an identity provider. Then the other concept is obligations. These are actions the policy enforcement point must perform after a decision. So allow read and log to SIM. Let's say that could be a rule for after a particular triage and particular logs are isolated, then a SIM can be given, or a SIM role can be given access to allow read, and after read and log to after particular logs are curated, then they can be logged by a SIM, and they can also be passed by a SIM. And then finally, we have advice. So advice is here, you're looking at non-binding suggestions. For example, one user, if a file is confidential, if it's classified as confidential, then one the user. So this is an advisory role for the policy-based access control method. So one other thing is it is defined by standards such as the extensible access control markup and the alpha, or the abbreviated language for authorization. So that is a standard around policies. The technologies that we will be speaking about when we look at policy-based access control are Open Policy Agent, OPA. We have AWS Identity and Access Management Policies. We have Azure RBAC and conditional access. So from a GRC point of view, that is governance, risk, and compliance, policies enable central governance and audit trails. Then They also support continuous compliance. Let's jump into the fourth model of access control model, and that is relationship-based access control. So ReBAC, as it's known in short, models access based on direct relationships between subjects and objects. It has been popularized by social networks such as Google Zanzibar and platforms like GitHub. The core concepts are relationship tuple. Here you have an object, a relationship, and a user. View this as a row in a database table. For example, you could say a document XYZ is owned by the user Alice. And then one other characteristic is a graph-based model. So view a relationship as a directed graph. So the authorization state is labeled directed graph. And then we have transitive relationships. So this is the concept whereby if Bob is a member of Team X and Team X owns Project Y, then Bob can view Project Y, can view the milestones, all the resources relating to the Project Y. Then the other concept is rewrites. Rules are defined in a relationship in terms of others. For example, can view is given to the owner or member of a particular team, right? Then we have a check API. So here it's given in the form of user, permission, and object. Then the given traversal of the graph then returns a true or false. So that's the check API, where now you're moving from the user, the permission, and the object. So that if that traversal returns a true, then you have access. If it returns a false, then you have no access. So that is what we mean by the check API. So for example, here you have, say, Google Drive. And Alice can edit a folder because she is in the group that has editor relationship on folder A or within Google Drive. So that's an example. So what are the key concepts of relationship-based access control? So we have graph databases, we have object relationships, we have delegated access. The use cases for these are, for example, software as a service platforms. We have collaboration tools. We have as I said, social platforms, right? So like Google Drive, where you can like even Office 365, SharePoint, those kind of applications. Then let's move to a very interesting model, which is zero trust access control. This is a strategic model, not a protocol per se. So assume no implicit trusts have been issued. Every access request must fully be authenticated, authorized, and encrypted. What are the core concepts of zero trust? So the first concept, is I like saying, is never trust, always verify. Even internal network traffic is treated as untrusted. Location is irrelevant here. Then we have micro-segmentation. We have fine-grained perimeters around workloads and data or any other resource. Then there's continuous authentication. In zero trust, not just login time, risk score is updated during sessions, right? So just-in-time access is another attribute. Privileges are granted temporarily, automatically revoked after use. So these are ephemeral permissions, short-lived permissions, or privileges granted for a particular cause, right, or for a particular reason. Let's say the database has gone down, the replication has had issues, and you want to give a DB permissions, even though it's at night or an odd hour, right? So an overall user, let's say the chief DBA, can give rights or access to particular functions or roles in the DB to a junior DBA to resolve that just in time access, right? So the other concept is the concept of least privilege dynamic. So permissions here are granted only for a specific resource, action, and duration needed, right? So you're only given what you need, barely what you need, and nothing more. The implementation of these, so often we'll use ABAC, attribute-based access control in Zero Trust. You'll also see implementations that are incorporating identity-aware proxies, such as Beyond COP, and software-defined perimeters, such as SDP. So what are the supporting technologies of Zero Trust? Here we have identity-aware proxies, we have multi-factor authentication everywhere is a policy. We have endpoint detection and response, EDR tools. So let's talk about GRC alignment to this. So here we have a strong alignment with CISA's Zero Trust Maturity Model that maps across IA, identification and authorization, identification and authentication. We have AC, access control, and audit and accountability. So that those elements will be mapped across the Zero Trust Maturity Model, right? Now, so that was Zero Trust Access Control Method. And then we have Risk Adaptive Access Control. Very interesting one. So RADAC, or Risk Adaptive Access Control, adjust decisions based on real-time risks. For example, user behavior and threat intelligence. What are the core concepts of risk adaptive access control? Here we have risk score, which is calculated from factors like location, device health, past violations, and data sensitivity. Then another concept is operational need. Users' requirements to access despite risk, e.g., emergency break glass. You always have that for you to do activate an alarm, break the glass. So that is an adaptive control, right? Then we have thresholds. So if the risk is greater than a threshold, then deny or step up authentication, right? So if someone has logged in into your Google account from a different device, from a different location, then throw a second factor of authentication. So that is an adaptive example of a control, right? So you could say if the user is logging in the location they're used to, in the device they're used to, then do number matching. Show them a number like 84 on a prompt in your Mac or PC, and ask them to enter that number from their mobile device. You see? So, and then we have the final concept in this adaptive control is continuous monitoring. So risk updates during session, e.g., user downloads 100 files in 1 minute, then that raises an alarm and revokes access immediately. So use cases for risk adaptive control is a banking system allows low risk transactions from home or from a particular geographic location, but deny high value transfers from a new device without OTP. Or, for example, in an ATM, you can only withdraw a particular amount, but on the banking app, the threshold is a bit higher, or you can only increase the threshold explicitly, right? So what are the inputs here? Here we are talking about a user behavior analytics, UBA. We talked about user entity behavior analytics, right? Something like that in our last discussion. So here you're taking user behavior analytics. You are looking at the user, how they typically use the system, and probably forming a baseline that if they deviate from that, then you can escalate the controls, right? Then another input could be the geographical context, the anomalies. So if you usually log in from one city or state, then all of a sudden you're logging in from another state or country, then it becomes a bit suspicious. Then we have the device health. You can require that the devices trying to join your access points have various patch levels, are using particular um, antiviruses. Uh, so that's it. The device context. You could even require that the devices that are logging in into your system are not rooted, right? They are not jailbroken. Yeah. So that's the device context. And then finally, we have the threat intelligence that keeps these systems smart and adaptive, right? So an example could be, let's say you require MFA if logging originates from a new country, right, as I have explained. So from a GRC point of view, this model supports continuous monitoring. Uh, as mentioned in the NIST RMF Step 6, it enhances risk-based decision making. So that's it. Um, it is always good to know how your door unlocks. I have to say, the bottom line here is access control is no longer a one-time check at the gate. It's a continuous conversation between your identity, your context, and your data. Whether you lean into ABAC, layer in ReBAC, or adopt a full zero trust architecture, the direction is quite clear. Static is dead. Dynamic is the flow or the baseline. The systems that survive will be one that asks not just who are you, but should you still be here every single second. Thank you for watching Gumzo Cybersecurity Podcast. It's always a pleasure. I've said, keep safe. Till next time, get to know your gate and how it operates.